Last slide of the day. Here we go. Technique not included on the AP exam but helpful for taking hard derivatives is called logarithmic differentiation. It essentially says to take the natural log of the hard expression in order to take advantage of the log rules. In other words, what it's telling me to do is take the natural log of each side. Then I can use the algebra to implicitly take the derivative of the rest. So let's do that. Natural log of y equals natural log of this beast. We got 2x minus 1 to the third power over x squared plus x plus 1 to the 1/2. Now again, try to see this in pieces. What I really see is natural log for this right here. I see natural log of a cubed over b to the 1/2, which is really going to be natural log, or 3 natural log of a minus 1/2 natural log of b. So if I were to do the algebra then, we have natural log of y on this side equals 3 natural log of a happens to be 2x minus 1. That's my a. This is my b. Minus 1/2 natural log of x squared plus x plus 1. That seems like a lot of work, but remember when you do the algebra first, the derivatives seem to be easier. So for the first one, natural log of y, take the derivative of both sides. This is going to be 1 over y times dy dx equals. Well, here let's say that u equals 2x minus 1, then u prime equals just 2. And you know what, in fact, I'm getting a little bit crunched on space. Let's just write down the u prime, because we know that if this is u, then u prime equals 2. Similarly, if this is w, then w prime equals 2x plus 1. So here we have 3, because the constant multiple rule lets us just drop that down, times u prime over u minus 1/2 times w prime over w. I'm going to leave this 1 over y here and go ahead and multiply these, or substitute these pieces in. This is going to be 3 times u prime, which is 2, over u, which is 2x minus 1. That's my first term. Minus w prime is on top, 2x plus 1, over, we got 2 in the denominator, times w, which is x squared plus x plus 1. Over here we still have this 1 over y. Now if I wanted to get dy dx all by itself, all that I would have to do is multiply each side by y. I have the dy dx by itself. The real question is, though, what does y equal? Can anybody guess? Give you hints. It's in the very first step. So if I were to simplify this, we got 6 over 2x minus 1 minus 2x plus 1 over 2 times x squared plus x plus 1 times y. What is y? I'll give you a hint. Y is this big old function that we originally started with. It's going to be times 2x minus 1 to the third power over the square root of x squared plus x plus 1. And we're done. We have the derivative. How did NASA? Well, it allowed us to take the parts of this complex function and separate it into individual pieces that were a lot easier to take the derivative of. We could take the derivative of this natural log and this natural log. And we could even take the derivative natural log of y over on the other side. But we couldn't do that until we took it apart. You can't take derivatives separately unless they're separate terms with either adding or subtracting in between. That allowed us to get down to here. You'll find that this 1 over y being left alone and kind of hanging out there and then multiplying by y later, that happens pretty regularly. That's how you use this strategy. Because you're going to wind up having 1 over y dy dx on one side. And then eventually, sometime, either in the middle or at the end, I like to do it at the end, you got to multiply by y. Okay, that is this lesson. The end.